Let's take a look at the hyperbola. When we're graphing our hyperbolas, you're going to notice that we have some of those same type of points. We are going to be looking at a center, which for right now I'm going to go ahead and draw mine at the origin. We're also going to have a couple vertices on our hyperbola, and the foci are going to appear on the inside portion of the curved section. In this case, the line that cuts through my foci, the vertices in the center, is known as the transverse axis, which in this case would be the x-axis, and the other axis is known as the conjugate axis, which for us would be the y-axis for right now. Let's go ahead and take a look at the basic equations to set up our hyperbolas. Our general formula is x minus h, the quantity squared, over a squared, minus y minus k, the quantity squared, over b squared, equals 1. The letter a is still going to represent our distance from the center out to one of our vertices. The letter c is going to represent the distance from the center out to one of our foci. And keep in mind, your distance out to the foci are going to be farther away from your center than your vertice. So when you're calculating that distance, we're going to be using this formula c squared equals a squared plus b squared. And that makes sense because we should be adding these two numbers together to get our c value. That's going to be the piece that makes our foci appear on the inside portion of the hyperbola. And if our center is at the point 0, 0, then obviously our equation is going to simplify to x squared over a squared minus y squared over b squared equals 1. And we're also going to be graphing some asymptotes, and our general equation there is going to be y equals plus or minus b over a times x. Let's go ahead and take a look at this example, and then we'll take a look at the graph. In this example, we have x squared over 16 minus y squared over 4 equals 1. One of the first things we'll recognize about this hyperbola is that it's going to be centered at the origin. Since our x term comes first in this fraction, then our transverse axis is going to be the x-axis. And now we can start working with the 16. That is our a squared value, so we know our distance from the center out to one of our vertices is going to be 4 units. We're going to be taking the square root of 16 to get 4. We also know our b squared value is 4. That means b is going to be equal to 2. We're going to need that number when we have to go find the asymptotes. Remember that our equation for those asymptotes is y equals plus or minus b over a times x. Let's go ahead and get those two equations. When we plug in our values of 2 and 4, we're going to get two equations here. Y equals 1/2 x and y equals negative 1/2 x. Now let's go ahead and find our c value, which is our distance from the center out to the foci. We're going to be using the equation c squared equals a squared plus b squared. And we're going to be adding these two numbers, the 16 and the 4. That's going to give us 20. And then we can go ahead and take the square root. So our distance is going to be radical 20, and that's going to be the distance from the center out to our foci. Let's go ahead and start plotting some of the information that we have. Our center is at the origin, and remember that our distance from the center out to the vertices was 4 units. So that means one of our vertices is going to be at negative 4, 0, and the other one is going to be at positive 4, 0. our x-axis would be our transverse axis. Now, before I go plotting anything else, I'm going to go ahead and draw my asymptotes on here. That's going to give me a nice indication as to where my hyperbola is going to sit on my graph. Remember that you are drawing your asymptotes from the center. So let's go ahead and graph the equation y equals 1/2 x first. So here's my first one. I started at my center, and in order for me to graph the equation 1/2 x, I'm counting up 1 unit, and then to the right 2 units. I put a little dot there, and then I did the same thing, count up 1 unit and over 2, and that's where I'm going to draw my dashed line for my asymptote. Let's go ahead and draw the other one. Our next one is the equation y equals -1/2 x. So I'm starting at my center and I'm counting down 1 unit and then over 2. Down 1 unit and then over 2. And then I'm going to go ahead and connect those with a dashed line. Once you have it graphed, go ahead and label each of those with their respective equations. Now let's go ahead and put our foci on our graph. Remember that our value for c came out to be radical 20, which is about 4.5 units away from our center. So I went ahead and plotted both foci on my graph, and I labeled my coordinates over here off to the side. And now the last thing that we have to do is to go ahead and draw the hyperbola. The fact that I have my asymptotes already drawn on my graph, I can go ahead and draw my hyperbola. It just needs to sit inside those asymptotes. So here's a final image of my graph, and you can see that this hyperbola opens to the left and to the right hand side. Make sure that everything kind of matches up. Your foci should be on the inside curved portion of your hyperbola.